Oh, hello. Good day. Good afternoon. This is our first webinar of our webinar series. Today we're gonna talk about SAP Datasphere. Um, we will have a short introduction to Datasphere, what it is about, what it means in relation with the concept of data fabric and business data fabric. Then we have a second part, which is a short presentation about how you can do machine learning with data that resides in a Datasphere tenant. We have a short demo prepared that uses the most important libraries that are available for that. We will use Jupyter Notebooks to access the data. And as a third part, we will have a short look into how you can upskill to get productive in Datasphere, especially if you're coming from a BW background, um, where some different concepts are being used. So it is important that you switch to the ideas and the concepts of Datasphere, and we will give you some pointers about how you can do that quickly. Good. Then let's move to the presentation, which will help us along the way. You should see it by now, and we get this started. So with me is also my colleague Antonio Leites. We together developed the content of this webinar. My name is Philip Nell. I'm the lead for data warehousing, especially SAP data warehousing here at Sulzer, Spain. Who is Sulzer? Sulzer, not to be confused with the Swiss Sulzer pumps. Sulzer is a German consulting firm with headquarters in Munich. And if you look at the subsidiaries, the German subsidiaries, you will notice that they are all in the cities where the main German car manufacturers are residing. So in Munich, you have BMW, MAN, for example. Then we have Ingolstadt, which is Audi. And I see that it's not passing the slide. 1 second. Now here we are. Yeah, so Munich, Ingolstadt, Stuttgart, which is Porsche and Daimler, Wolfsburg, which is Volkswagen, and then Sulzer also has other dependencies in Budapest, Szeged, Mount Vale, this is US, and Hyderabad, India, and Sulzer, Spain, which is headquartered in Madrid. Our focus is mostly the automotive industries. However, we are also working for other industries like fast-moving consumer goods, healthcare, and financial services of different kinds. And so we have a continuous exposition to large landscapes with a certain degree of complexity, which helps us to design analytics and data management solutions of scale. And within that practice, Datasphere is also now part of our work. So what is a data fabric? One can imagine a data fabric is like a central piece of collection of data of different types, like structured data, of course, table data, but it also can be semi-structured, like JSONs and similar formats, and also unstructured data. And within a data fabric, we find all the necessary functionality that allows us to fulfill different functionalities, which you can see here on the right side. This includes self-service, it includes data discovery, orchestration, processing of data, virtual access, if possible, governance, data and data ingestion, so everything that is related with bringing data to the fabric so that we can process this data there. Another important point, which is related with data discovery and governance and in general, good practice is semantics. So we have the possibilities to describe the um, the meaning, the real true world meaning of data assets that we have. We can understand much better how to interpret this data and, for example, where the data is coming from and what type of transformations to the data have been done so that the correct interpretation of data assets is possible, not in a given moment, but also throughout the whole time of existence of the data in our fabric. Data fabric is a concept that was described first by Gartner, and here in the slides so we included this link that describes the requirements and the idea of a data fabric in more detail. So we don't have too much time. I just have here the main page where Gardner describes this idea. And if you have a read through it, you will see that the important things are this general validity for processing any type of data, creating these data assets and making them available in a clear, understandable way. It also includes functionality for let's say, advanced data introspection, which is the part where machine learning is applied to the data to get new insights and probably with these new insights also feed the business processes directly to make them more intelligent. SAP is extending this idea of data fabric, calling it a business data fabric. So this can be understood that there is a deeper focus on business processes. Well, everything is, of course, business data, but SAP, and because also of its origins, has a more much more focused view on business processes and how they are described. And SAP offers in this link a more detailed look into its ideas about what data fabric are and what the benefits are, of course, of using such idea and concept. One can say that a data fabric is for sure a very holistic approach to data management with a lot of flexibility. But if we look to the corporate information factory that maybe some of you have heard beginning of 2000 by Bill Inman, it also includes this idea of central data management, even if by then not all of the functionality was covered or was being thought of, as we are talking about an idea that is more than 20 years ago. For data architectures in a data fabric, there are different approaches, even if we will see that there's not so much difference between them from a logical perspective. There might be naming differences, but we have here on the left side the medallion architecture is proposed or described by Microsoft, where we have a bronze layer, a silver layer, and a gold layer, and each layer adds some informational value to the data, which might be everything from making data more homogeneous, normalized, to adding analytical application logic and extended interpretation of data for a given purpose, and which has the focus of data that it can easily be used by the end users with the different services of data access that might be available. SAP proposes as a data architecture, not a 3-layer, but a 4-layer. But at the very end, it is pretty much the same. So the bronze layer is the inbound layer, propagation, harmonization can be included here in the silver layer. And then we have the reporting layer, which is similar to the gold layer, where we have rich data with a lot of additional information around it, like semantical information or quality information. So we have very similar approach. And if you look at that, you might be reminded also of a BW architecture that was in place for decades now, which is the LSA, no LSA plus architecture. So again, we are able to show that while ways and methods might have changed throughout the time, the logical approach to how we manage data in a data fabric environment hasn't changed much during the last years. Good. Then why Datasphere? So first of all, it is the mean to implement this business data fabric. It is a cloud-based SaaS solution, so you have something which is quickly being made available. You don't have to worry about technical details. It's just given to you. You have SAP HANA Cloud with its still lightning fast data access engine. So you have a solid technical foundation with a high degree of focusing on what you really want to do without having to work too much on the operations part from a pure technical perspective. Especially in the integration part, I would like to emphasize the, as expected, very good integration with SAP applications. SAP integrates best with SAP. And once you dive in, you can see how easy, how straightforward is the integration with even complex to very complex data models that are being provided by ECC or S/4HANA. And if you have a BW infrastructure, you can also very easily integrate this data into a Datasphere tenant. Yeah, this is pretty straightforward. And depending on which version of the systems you're using, it might be a more replication-oriented integration. On other systems, we really can think about a pure virtual integration, which gives us the possibility to make use of Datasphere functionality on existing BW for HANA structures, for example, without the need to duplicate or to transfer data from one system to another. SAP knows about what is required by corporations to run large-scale systems. So this is also now in place in Datasphere. We have a very important concept, which is the workspace. We will see next slide how we can understand the workspaces. It's primarily a functional bag where you can put data assets that are related, for example, for sales or for the finance part, and which allows to quickly create this functional grouping and to easily implement also functional isolation between the different workspaces. Yeah, we have enhanced data governance capabilities, tracking, rich semantics. If we just look at SQL, many details about how to interpret correctly data are not made available within pure SQL, which is the base for many other data warehousing solutions. But we can include like the fact that a field is a currency field and that the corresponding currency or is an amount field and the corresponding currency field is this. So these type of connections between the data and interpretations, they can be easily integrated and managed in Datasphere. And if you have a BW or BW for HANA system, you can make use of certain functionalities that allow you to use your existing assets and transfer them in parts in a automated way to a Datasphere tenant. In that case, if you want to use really BW functionality in your Datasphere, you have the option to go to the BW Bridge, which is basically a cloud-based BW for HANA system for staging. Good. Then let's have a look at the architecture. Let's start here with the Datasphere core. I already mentioned these workspaces. Here, this workspace, let's say that's a master data management, which can send data to other spaces, so artifact sharing, these arrows. What do they mean? It means that we can publish data assets from one space to another without having to replicate necessarily the data. That allows us to create within the corresponding workspaces, like if necessary, the physical representations of the data, add some logic that is desired and required, and then publish these structures to other spaces where they can be used. Like if that would be a central master data space, it can send its master data definitions to other spaces. These spaces do not have to worry about technical implementation details. They just use this asset, and then they can create their own functionality, including these shared objects. Then we have here the Datasphere UI. So we have modeling, which is data builder and the business builder. Data builder is more the technical thing where you define views, semantically rich views, but you still have certain, so very close to technical aspects of the data. And then there is the business builder, which includes this idea of self-service model creation, where end users with a certain interest can obtain a technically less detailed view on the data and can easily recombine them to their liking so that they create their own data assets without having to know about SQL or relational logic too much. We have different functionalities for monitoring and administrating our Datasphere tenants, especially of interest when we have data flows that need to be controlled, that they have been executed and scheduled correctly. So that is also here included. And then we have the BW Bridge option, which is a BW system based in the cloud. It offers the staging capabilities for ODP so that we can transfer data via ODP into this part, and that these structures that are maintained here, they are published to a so-called BW bridge space, which is then the jump point to publish BW-based views to the different workspaces we have here. And from the integration perspective, we are having a lot of different possibilities, cloud-based, non-cloud-based, for S/4HANA, which is a very important source of information that will be likely managed in Datasphere. We have up-to-date integration techniques, CDS. It includes also real-time replication for suitable CDS views. For other cloud solutions, we have cloud data integration, and we have the possibility to do all this with either S/4HANA in the cloud, public cloud, private cloud, or even on-premise. If you have to integrate an ECC, we can still use the well-known extractors. They can be integrated into the bridge if you want to apply stage and logic in BW fashion, but you also can publish these into the workspaces, so you can implement pure Datasphere related transformation logic in Datasphere without the BW bridge. And then we have BW for HANA, which also integrates in both parts, of course. And but there is a different or an additional functionality which is very interesting. It's the BW for HANA model transfer that allows us to publish structures and the data that belongs to them in a BW for HANA system directly into Datasphere, and allows us a pretty well performing virtual access to this data, giving Datasphere or making Datasphere an additional functional layer on top of data that is managed in a BW for HANA system. How does this look like? So here we have a couple of screenshots that should give you an idea about how you work with Datasphere. On one side, we have the integration to multiple sources of any kind on premise or cloud sources. What we see here, this is a data flow that reads from an S3 bucket where we have a CSV file. And once you have configured the access, it's very straightforward to bring the data in so that Datasphere has full access to the data that is stored in there. Here we have a screenshot of the low-code tool for developing data transformation logic. We have here two incoming structures. We apply certain functionality to it with this function operator, and then we make a union in this case of the two flows to create a new output structure. Of course, this is a very simple example, but you can express here in a pretty clear way how you want to deal with the data and how you want to let the data flow initially just logically. This is a virtual model, but the nice thing is we can decide on any point of these views, so at any endpoint of a view, if we want to create a persistency for that, in case that the virtual logic does not perform as fast as required. But again, we have HANA Cloud underneath, and HANA has already demonstrated for many years that it's very, very capable of executing even complex queries in a more than satisfying way. We have a repository explorer, for example, that allows us to find structures throughout the whole tenant. We have a data marketplace, which can be used for external data or to integrate external data, but it can also be used to publish internal data to companies or to the company if you have different Datasphere tenants, for example, or within. So here we have the idea of considering data as a data product and publish this to corresponding interested parties. We have a data integration monitor for all the data flows and data movements we have, where we can check if they have run correctly or analyze if something didn't work, what were the reasons, and for example, what were the run times for the different steps. And of course, we have a database level access, which is the HANA Cloud Database Explorer, where we access directly the HANA Cloud instance underneath our Datasphere tenant for a direct SQL access, which might be of interest for different purposes. And with that, we come to the second part of today's webinar, which is a short look into how we can imagine data machine learning with Datasphere. And you see already, we have here a Jupyter Notebook-based environment with which we can access the data that is stored or being accessible here, and we can prepare the data and then run trainings of models according to the business requirements. And the nice thing about this integration is that the HANA machine learning client, we will see that right now, is not taking the data to the Jupyter Notebook. So when we use the machine learning client, we can work with data frames, very similar to Pandas data frames, but the data frames of the HANA machine learning library, they only are pointers to data sets that reside physically in the database. So not transferred to the front end. So we just have the descriptors of these data sets that reside here. And then once we have a data set that seems valid for us for a machine learning process, we kick off the machine learning process, making use of the extended CPU and memory resources we have available here, so we can run much larger processes of machine learning without having to overload a local PC where a data scientist might work. Then we have also an integration with another open source package, which is MLflow, which serves for tracking of models, of the metrics, of the evolutions of versions, hyperparameters. So here we have the possibility to follow our experiments and track them and the evolution. So that is also an interesting part. We will not have a look at it today, but just for you to know that this is now also integrated in the HANA Machine Learning library. Then we have here a short summary about the two relevant libraries that exist in HANA Cloud for machine learning. One is called the Predictive Analysis Library, with plenty of algorithms for these algorithmic categories. And then there is the APL, which automates certain processes compared to the predictive analysis library, but as a downside, does not offer the richness of the algorithmic implementations we have in the predictive analysis library. Good. Then let's have a look at our example for machine learning. And we see here our notebook. This notebook, it's a short one, but I think it's a nice example to see how you can imagine working with a Jupyter Notebook against data that resides in a Datasphere tenant. So the first cell we have here, it's a longer version. There exist shorter versions of connecting to a database, and we just executed. We are successfully connected now to the system, and now we create a first data frame, a remote data frame, which reads all the data that exists in a table, which is called WSML filtered guests. So this is a data set that came from the evolution of visitors from different countries to the different regions in Spain over the years. And they have been stored here within Datasphere. And with this cell, we can load now a remote data frame. Again, no data has been transferred here to the client. Everything is in the database, and we can have a look at it, and we get some information about the data, and we can also collect some statistics. Again, this is all executed on HANA side. There's no data here on my local PC. Have a look into the metadata, the definition of the data types, and now we want to continue investigating our data. And we have seen that total persons, which is something numerical, is not stored as a integer or as a numerical value. So we create a new data frame, let's override our existing, in this case with a select statement that reads from the table we just have seen before. But this DF remote, I said that this is a descriptor of a data set in the database. We have with a select statement the possibility to see how is this data set described in the database. And it is described by an SQL statement, as we can see here. And this is the way how this works. So every HANA remote data frame is at the very end a more or less complex SQL statement that describes the data set that we are preparing with our single processing or single step processing we are doing here. So here, for example, we have this set of columns. We don't need them for our objective. Some of these columns we can drop. This happens here. Then we will apply a filter. We drop some data. We don't want to have it. So here we are operating directly, and I can change this without any major problem. And we get additional information, or we concentrate this data frame on exactly the data we want to use in the next steps. So we have now 34,000 records. This is because we applied this filter, and we also see the total persons 1K is now really a numerical value because we have here some statistical information about this column, which was not available before. Let's execute again the select statement. And this statement, and you see that's a pretty complex statement, is the statement that is behind this output here. So whatever we do, corresponding select statement will be created, will be executed in the HANA database, which gives us the possibility to formulate complex data set descriptions on a step-by-step basis. So we don't need to formulate the whole SQL statement, which can just increase or evolve our data frame with the different operations. And then we have access to it independently if it is a very complex or less complex statement. And a nice feature is the unified report coming with the machine learning library, because it gives you easy to use information, in this case about the data set. So we have our 34,759 records. We have 6 columns. The memory that is being used here, some visual information, here some access to some samples of the data we have available. So here we get some visual help to understand our data better. Now we continue working on our remote data frame. We want to aggregate it by date month or group by date month. This is enough because we don't want to look into this first exercise into the details of region. We're just looking into time, and we sort it, and here we get our result. Again, this is another select statement that is behind, and this computation here is done on database side. And having now prepared our data, we want to train a time series, a model that allows us to do a forecast of a time series evolution. And this is happening here. So here we take specific time series forecast algorithm. It's called additive model forecast. We create it as an instance, and then we run it on our data, which we have prepared previously. So data frame remote aggregated. So that's the data we are using here to create this this model. Good. So we have now trained our model. It's a small data set, that's why it's especially quickly. And again, we have our unified report that allows us to have a look into the model and its qualities. This is coming all out of the box. So here we see the evolution of our historical data. In summer, we have our peaks. In winter, there are less visitors. And here we have the Corona crisis clearly visualized. And then we see that it is going up again. We have more information about this time series. And with that, now that we have created the model, we want to do a forecast for the next 12 months. And for that, we define a date, which is the month of the last data we have available. So that was, you see, that is a pretty fresh, recent data set. There's data until July 2024. And now we will create like a container in which we will project our forecast based on the historical data and the model we have trained. So these are the months to be forecasted. We have no target values yet. But now we do the forecast. We apply our model to the data in order to get a forecast for the months that we have prepared here. These are the numbers, the output, still not easy to fully understand. But again, as we have our unified report, oh, here we are. And we see here we have our 12 months, and it's not very difficult to see that this is likely right, as we have only 1 year. Yeah, but it's also good to see that if this would be a more complex pattern, it would be harder for us to estimate how the evolution, the forecast would look like. As this is very seasonal with very clear structures, it's not very surprising that this is the forecast, but it's also a good confirmation that everything worked correctly. And if you have a look at it, here you also see the corridor, yeah, the maximums and the minimums that could be expected, and this is the mean value that has been determined. Good. Then some more steps for finalizing. We are preparing now a data set that has everything together, the actuals and the forecast, which will be now stored in the database. So that's the statement that has everything together, quite a big one. And we will save this now in the database for further use. And with that, we come to an end of this demo. Even within the short time, I think you could see the idea of how to work with that data that we have in Datasphere. Very modern. We couldn't think of something similar in the old data warehouse approach we had. And especially this incremental process of getting our data prepared for our algorithms. That's something very intuitive and common. And now we have this available for our Datasphere data, which is often already very well structured and very good from a data quality perspective. And we can operate in this way in order to find additional interesting insights into our data. Good. And with that, we return to the presentation. And let's have a look at some aspects if you want to scale up for Datasphere. And the first important thing is to know that Datasphere development is highly relational. So we make much use of relational ideas like joins, unions, intersections, so these relational data set operators that we know from SQL. And the more SQL understanding you have, especially of these relational operators, the easier it will be for you to develop also complex logic and data transformation logic in Datasphere. Datasphere has access to the full library of functions that is offered by SAP HANA Cloud. Of course, these are all like these string operations and the data type conversion functions that you can expect. But one nice thing about SAP HANA database is that it also offers like these very specific SAP functionalities in simple function calls. For example, the currency conversion. Here, you can do a fully or a complete currency conversion as you know it from an S/4HANA system or ECC or BW system. If you want to do something like that with the different parameters that exist, then you can do that by using the corresponding HANA SQL function. Or if you want to calculate the workdays in dependency of a fabric calendar, there is a function for that. So it's important to know which functions you have available so that you can use them and not define these functions again on your own, which will be on one side complex and much more error prone than using these out-of-the-box functions. So it's important that you know which functions are offered by SAP HANA because you can use them in Datasphere. For more complex analytical results, SQL offers the so-called window functions, which allows you, if you have a bigger data set defined by the where clause, to describe windows on which you can determine, for example, a ranking function. And this is also a functionality, while for database developers of other databases, they are nothing new. For people that come from BW, they might never have heard about them. So it's important that you take notice that they exist and that you start understanding the idea of the window function. And sometimes you might face logic that cannot be easily, at least, described with relational logic. In that case, we have HANA SQL script, which adds like more iterative um, um, expressions, like if then else, while, loops, etc. This is all described in SQL script. So SQL script combines the power of HANA SQL with the possibility to implement logic that is beyond the capabilities of relational logic. And here's some links to some more information. Of course, the documentation of Datasphere is a good point, and have a look into HANA Cloud. As said, the SQL reference is of much importance and use. Here, the nice thing about the SQL reference is that all functions and statements, they come with a lot of examples. So these are usually pretty straightforward. You just copy the example and you can run it in a HANA database if your user has the corresponding rights. Then there is a learning journey available at learning.sap.com. This is good if you want to understand the concepts and the terminology that is being used in Datasphere. And then in the Discovery Center of SAP, you can find a set of missions. So here you can get a trial version of Datasphere. This one unfortunately does not include the machine learning capabilities, but you can use a HANA Cloud trial for that. So you have access to practice this independently if you have a productive tenant of Datasphere available. And if you want to have a guided approach to Datasphere, if you don't want to do this by yourself, we have defined the Datasphere Starter Pack, which is focusing on a quick ramp up of you and possibly your team. We offer an integration to one of your SAP systems so that you can bring in data to your Datasphere tenant, your own data. And then we offer a 3-day enablement workshop, which is a walkthrough through the functionality and the concept, and which can be focused on your own data, so that your first exposure is in relation with your own environment. This can be extended later into reporting with SAC, a deeper look into the machine learning capabilities we were discussing before, and of course, from there, if you need further support for your Datasphere journey, we are happy to prepare a corresponding offer for you. Yeah, with that, we come to an end. Thank you very much for being with us today, your time, your interest, and yeah, wishing you a great day. Bye-bye.